Okay, so in Pascal's triangle, you can see that anything, and again, this is not even with Pascal's triangle, anything to the 0 power is what? 1. So even if you have the most disgusting polynomial inside here, anything to the 0 power is essentially still 1. So for number 1, your answer is just 1, right? Okay, so number 1 is pretty easy, right? X plus y to the 0 power is just 1. The second one, you can see here, anything to the first power is just itself, right? It's just itself. So for the second one, your answer would just practically be x plus y, right? It would just be x plus y. So again, we want to think about the power of exponents. What does it mean? How can we apply this? Okay. That's it, x plus y. Okay, so the reason we have the binomial theorem is because if you can predict a way to expand polynomials, then we can just go ahead and program something to do it for us, right? That's why your calculator can probably do it, right? And so when we're able to understand something, then we can predict what the next few steps will be like, which is great. So when you're given something like this, it's very easy to just expand it. You can FOIL by multiplying, distributing. But then when you're given something like number 6, then it seems startingly almost impossible, right? So number 3, we're going to try and do this by using Pascal's triangle. If you remember, for 2, the expansion is 1, 2, 1. So you would do 1, 2, and 1. I'm just going to write it like this for now, right? So your expansion is 1, 2, 1. How the expansion of this goes is that, I'm going to go ahead and put this in parentheses and you'll see why, is that the first term is going to be squared, right? It's going to be the largest exponential value. The second term is going to be one of each, so it's going to be x times 2, which is the second term. And the last one is going to be the second term squared. Okay. So this would be plus and plus. The reason is there is a plus here. So this is going to be 1 times x squared plus 2 times x times 2 plus 1 times 2 squared. And if you were to expand it out, you would get the same answer. You get x squared plus 4x plus 4. Okay? Okay, so this one seems a little more doable, right? You only have 3 terms, right? And again, if you were to distribute, you would actually get the same answer, right? You're going to get the exact same polynomial. And again, this tool is more useful when you start getting to polynomials where you can no longer do it by, or you can do it by hand, but there's a lot more room for mistake. All right, I'm going to split this video into 1 through 3.